So mark your quiz. Of course, got to go with my favorite student, good old Anne. Number 1, what is the unit of force and what is its definition? Okay, for 2 marks. Well, first of all, for 1 mark, what's force measured in? What are the units of force? Newtons. You can write a capital N or you can write the word newtons if you wish. 1 mark. Get the quiz? Were you going to tell me? Yeah. Do you have a copy?
No, it's not.
Okay. Did you do it? We'll talk later. Okay, but folks, you can't just sit. You can't just sit. You got to let me know, and I'll get you one to follow along with, okay? So that, Newton, or you can write it out. What is its definition? What's a force? What did I say a force was? Well, you could do it a couple ways. You could give me the actual mathematical definition. F equals ma. If you said this, I'll give you a mark for that. That's great. Or if you said push or a pull. Anybody say anything else? Okay. Max, can you read to me question 2, please, my friend? Stop. That's the key word. Okay, by the way, so we've been using our tug-of-war analogy, our winner minus loser analogy. Here's what it's been. Don't write this down. We've said this. It's winner, and for some reason I got a squeaky thing here. I'll muck around with it later. Sorry. That's irritating. Let's try that. Minus. No, it made it worse. Loser. I got to pause the video because that's going to drive the screen. I said this. It's winner minus loser equals, what did we write over here? What? F net. Initially, we wrote that. And then eventually, I started saying instead of F net, you could just write instead MA. Max, what I wanted to point out is if I ask for the net force, what I'm really saying is don't freak out about a free body diagram, don't draw a big picture. All I'm saying is start with this. Start there. Did they give you the mass?
Say yes.
Did they give you the acceleration?
Yeah.
Oh, plug and chug. We'll get more complicated, but not right now. 2,400 units. Newtons. Yep. Number 3, Thomas, how many marks is number 3 worth?
3.
You know what? Probably multi-step. Hopefully you've clued in by now. That's kind of how I roll. Okay? So probably multi-step. It wants me to find the force on the shell. I think it wants me to go like this. And Thomas, what was the hint that I gave you? You know why? Because they gave me the mass. It's 65, but I don't see a meters per second squared. I don't see an acceleration anywhere. Even though, Riley, this question is saying find the force, you know what I'm going to spend most of my time finding? Acceleration. In fact, I'll go like this. Acceleration. Well, what else have they told me? What's that 770? Oh, good. Someone said VF, yeah, because usually people say V, and which one? V final is 770. That implies there's a V initial. Do I know V initial? Well, I'm assuming you've seen a gun fired or a cannon fired. What's V initial for any bullet or cannon or shell? 0. Yes? What else have they told me? So apparently there's an equation somewhere that has AD, VF, and VI in it. There is. Which one? That one. Right? Yeah, that one. Hey, you feeling lucky? Can you get the A by itself? So I want to get the A by itself. I want to get this by itself. Now, eventually, I'll deal with these, but first I need to move that over. How can I move that over? Yep, because then there's an invisible plus sign right there. So if I hear you correctly, and I think I do, you're saying the VF squared drops down minus VI squared. Now that gives you a 2AD. We're trying to get the A by itself. How will I move the 2 and the D over? Yes. So I think the acceleration is going to be VF squared 770 squared minus 0 squared all over 2 times 1.5. By the way, based on what you know of cannons and bullets and artillery shells, are we expecting a small acceleration or a big acceleration? What do you think? Yeah, I think really big. So if I get a big answer, Noah, that's going to confirm that I've probably done this right. If I get a small answer, I'm going to, maybe I missed a squared or did something wonky or something like that. You know, I got a gut instinct for kind of whereabouts I should end up, right? Is there more than one number on the top, Noah, my friend? More than one number on the bottom? So that means brackets around the top and around the bottom. Mr. Dueck, could you ignore that 0 squared? Probably. I suspect I didn't need to bother typing the minus 0 squared, but just for symmetry, so you can see that I haven't missed anything. And I get an, oh, that's a big acceleration. I get 197,633.33333. 197,197,633 meters per second squared. Got another latecomer. Oh, I weep. I'll tell you how the part marks and everything go, but now I'm going to take that acceleration and I'm going to plug it in right here. 197,633. Although, hey, I'm going to use my answer button. Is that right? Anybody else get that? Now, I'm going to write that in scientific notation. 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7 newtons. F equals 1.28 times 10 to the 7th newtons. Now, if you got that right, 3 out of 3. Otherwise, how would I mark this? How would I give part marks? I would almost certainly give a half mark if I just saw F equals ma. I would give a half mark if I saw VF squared equals VI squared plus 2AD. I would give a half mark if I saw VF squared minus VI squared over 2D. I would give a half mark if I saw that you had got the acceleration correct, and then I would give 1 mark for the answer, and there's your 3 marks. But if you got it right, Thomas, 3 out of 3. Is that a big force? Yeah. And it'll take that big a force to bring it to a stop. That's why artillery shells do so much damage, because forces come in pairs. When that hits its target, it's going to apply a similar force to its target. The target is going to get demolished. Max, we're coming back to you for a reason. What word is in front of the word force in number 4? Net, you know what? I'm going to start. If it's the net force, it's F equals ma. Hey, Kyle, what do they want me to find in question number 4, sir? Oh, get the A by itself. How would I get the A by itself in this equation, my friend? You couldn't have said it any better if I'd said it myself. Did they give you the force? What's force measured in, Kyle? Oh, yeah, 12. Did they give you the mass? 1.2. You know what? This one actually works out evenly. 12 divided by 1.2. Do you get 10 meters per second squared? Is that right? I put a period because technically I should go to 2 sig figs, because the 12.0 is 3 sig figs, but the 1.2 is 2 sig figs, so I should go to 2 sig figs. I've told you, Justin, I'm not taking marks off for sig figs this year, but I'll keep emphasizing it just to remind you. Okay? Oh yeah, and you know what? How many marks was this one worth, Thomas? That's kind of your hint as well. You cluing in kind of how, like when we're doing tests and stuff? There are hints in how many marks I make it worth usually too. Number 5, although each part is worth 1 mark, it looks like it's multi-step because it's worth a total of 2 marks. So it says this. A says, what's the average acceleration? I now have several ways to find acceleration. I have all the stuff from Unit 1. Don't write this down. Whatever had an A in it, Noah? But this unit, I also have this notion. So, let's see. If I wanted to use Kyle's equation from last question, somewhere in this question there would be newtons. Do we see newtons anywhere in the data that they gave me? And this is your hint. This is, Jordan, how you can figure out, am I using Unit 1 kinematic stuff or am I using forces stuff to find acceleration? Acceleration is a very key concept, and it's going to show up in many more alternate ways as well, as it turns out. So, I think I'm going to defic A equals question mark. What's that mean, Oscar? What I just underlined in red from rest. Thank you. I caught you zoning out. My timing is pretty good. I can tell with your eyes. Absolutely. You know, that suggests maybe they gave me VF, did they?
3.2.
Why is 3.2 not the final velocity? Go to the next line. Keep reading. Yeah, by the way, I couldn't find a way to keep them on. My word processor treated it like a separate, anyways. And it was also partly to see if you're paying attention. Rockets don't go 3.2 meters per second. That would be, you walk faster than that. So let's assume a rocket ship goes faster than you walk. What else? Yeah, you. Which is? So to find the acceleration, I'm looking for an equation that has A, VI, VF, and T in it. Is there one? Yep. Since you zoned out Oscar, I'm going to keep picking on you. Let's get the A by itself. I want to get this by itself. I'll eventually deal with that, but we always do our plussing and minusing. For how will I move this over? Minus. So the VF drops down like a domino. Ka-chunk. You said you're going to minus the VI, and then how would I move the T over? You are correct. I'm doing this in my head. Do you get 100 or 1,000? 1,000. Sorry, 1,000. Yeah. 1,000 meters per second squared. I guess technically I should go 1.0 times 10 to the third, because as I notice, 2 sig figs, 2 sig figs, 2 sig figs. Fair enough. 1 mark. Is that okay, Riley? Yep. Hey, Max, coming back to you. What's the word in front of the word force here? So you'll notice I haven't had to do a free body diagram, winner minus loser, little dilly-doo. Do I know the mass? 4.5 times 10 to the fourth, which is about the weight of the space shuttle. I Googled it. Do I know the acceleration? There's my net force, which I think is going to end up being 4.5 times 10 to the 7th newtons. It's powers of 10, and I can do that in my head. 1 mark. Number 6. Hey, Max, what word is in front of the word force here? So you know what? This is going to be, again, F equals ma and that kind of a thing. All right. What does part A want me to find? Justin, when it says how far, what's it really asking me to find? What does how far mean, folks? Yeah, well, sorry, you're right. Probably technically displacement, but I always get those mixed. D, sure. So D equals question mark. So now I'm thinking about all the equations that had the D in them. There's a bunch of them. I love the fact that you have your yellow formula sheet in front of you. What else have they told me? What's this 1.6, Justin, my friend? What's this? What are the units next to it? What does an N stand for? So what is this? Force, right? Yeah, okay. So I'm going to say F equals 1.6. Now, I don't have an equation that has force and distance in it, so I'm going to kind of put that in my back pocket. I'm not sure I'm going to use it. There's a mass here as well. Yeah? Justin, what's that mean from rest? What does that tell me, folks? VI is 0, right? Right. Sorry, I'm waking you up, kiddo. And what's that? VF is 12. Can anybody see? I need to do one more. Oh, by the way, Thomas, how many marks is this worth? I bet you it's a two-step. I bet you I have to use something to find something. That's not good physics, that's just good test writing. What else can I find that I need from what I've listed? Oh, how can I find acceleration? We can use Kyle's equation. We'll call that Kyle's equation for the rest of this unit. We'll name it after you. Okay. They gave me the force, 1.6. They gave me the mass, 6.4. I think you have an acceleration of 0.25 meters per second squared. Again, I'm doing it in my head, but yes, I hope. Correct me if I'm wrong. Holler at me. Okay. So now, I'm looking for an equation that has to have D in it. Probably has a V and other stuff. Kyle's staring. It's the same one you rattled off earlier, Kyle. Which one was that? Yeah, nice and loud with authority in your voice. Of course, we want to get the D by itself. And now this time I'm not going to give you any hints. See if you can do the whole schmear. Remember how weird that was a couple of months ago? But I'm telling you, if you wrap your brain around it, it sure is a nice shortcut. I could say something about it beats a little triangle thingy or something like that and stare at the back row, but I'll choose not to. Sorry. Hey, Kyle, keep going. What's VF squared? What's VF? Yep. Squared minus 0 squared. Yep. Okay. Whoop, wrong button. This one. More than one number on the top? Brackets. More than one number on the bottom? Brackets. And again, I probably could have ignored that 0 squared, but some of that would terrify you, so we'll go like times 0.25. Do you get 288 meters? There you go. For 2 marks, I would probably, let's see. I would probably give you, first of all, if you got it right, 2 out of 2, obviously. I'd give you a half mark if you found the acceleration. I'd give you a half mark if you wrote that equation. I'd give you a half mark if I saw that you had successfully got the D by itself, and a half mark for the answer. I hope what you're also noticing in my marking scheme, Nick, I'm really not that concerned with you getting the answer right. You could get the wrong answer and still get 1.5 out of 2. I want the method. Okay? Oh, what that also means, by the way, is, Nick, and I'll pick on you, suppose you didn't get the 0.25. Let's suppose somehow you divided and you got 3. I don't know how, but you got 3. If you put a 3 there, and you went 12 squared minus 0 all over 2 times 3, I would give you a half mark, and I would give you still 1.5 out of 2. I'll give you full marks for all the rest of it. So that's how I mark on your tests as well. If you make a mistake early on, I'll get out my calculator, I'll try and track, I'll walk through your calculations with the wrong data, but if you did the rest of it correct, I'll give you all the marks coming to you. The moral of that is, because we've only written a couple of tests with me, don't leave written questions blank. You can always get part marks. In fact, Noah, a good strategy is if you can't do a... Sorry, I thought I saw a headphone in your ear for a second there. My bad. Gonna freak. You would never do that, would you? Smile and no. Noah, if you, for example, can't get a part A, for example, for here, part A, if you're going, I don't know the distance, make up a reasonable distance. And by reasonable, I wouldn't let it be 1 trillion meters. I probably wouldn't let it be 0.5 meter. Something in between. Make a little note. Mr. Dueck, I can't do a I'm going to assume it traveled 1,000 meters. And if you now did B successfully and correctly, I'd give you full marks. Okay? By the way, Tom. By the way, my nephew's name is also Noah. I should be able to get that. What's B want me to find? Which one? Time. How many marks is it worth? Suggests maybe more than one step, right? Okay. How am I going to, what did you say we're asking us to find? You know what? First thing I'm going to do is this. I could re-defic everything else, but Alexa, have I listed everything in the previous line up there? Yes? So, you know what? I'm looking for an equation that has t in it, and hopefully some of this other stuff. Is there one? What'd you go with, Madison?
VF equals VI plus AT.
Can you get the t by itself in one fell swoop right now?
VF minus VI divided by
Oh, feel a nerdy, giddy feeling of pride. Do we have everything? Yep. There's other ways you could find t, and if you used a different method, show it to me later. That'd be, I think, the cleanest way. You could use the d equals VIT plus a half AT squared and get the t by itself that way. That involves doing a squared and some other yucky stuff. It's doable. You could use the the equation we hardly ever use, the d equals a half VF plus VI times t. There is that one on there. I hardly ever use that to the point where I don't have it memorized. I can always work around it. That would be fine. There may be other ways, but I'm going to go with this one. VF 12 minus VI 0 over A 0.25. Mr. Dueck, I thought you said this was a two-stepper. We're only getting there in a one-step. Well, it's because you're having to use something that you found up here. I made it worth 2 marks for some dumb reason. Oh, for Pete's sakes, I can do this in my head. 48, yeah? Noah, what did we find? 48 what units? We measure time in meters. What do we measure time in, folks? What? What are the units for time? Yes, right? Again, and I'm trying to model some stuff. Whenever you finish a question, last thing you do, check to make sure you put the units on. If you really want to impress me, put a box around your answer. You know what? 1 mark for that. I guess 1 mark for the answer. Turn the page, or next page over. Now we're going to be getting into some Newton's laws and some free body diagram stuff, because I see, for example, in number 8, an elevator of all things. A book is sitting on a level desk. Which of the following statements are true? There are no forces acting on the book since it's not accelerating. True or false? What forces are acting on the book? Get the obvious one. Is it sinking into the ground like quicksand? Is it flying into you like Superman? Then using Newton's laws, we can reason whatever gravity is pulling down with 10 newtons, the table is pushing up with 10 newtons, and we've given that force that inanimate object surfaces apply a special name. We call it the normal force. Oh, by the way, how many true-false questions are there? 4. How many marks is this worth? What would my marking scheme be, do you think? Yeah, half mark each. Try to, you guys are in your grade 11 and 12. It's high time you started cleverly thinking like test creators. Oh, you know what? I think I just answered B. Yeah, the magnitude of the normal force and the magnitude of the gravitational force must be the same. Why? Because it's not sinking into the ground like quicksand, and it's not flying into you like Superman. C, the net force on the book is equal to 0. True or false? How do you know? Because a second part of Newton's first law says if it wasn't 0, it would have to be accelerating. Is it accelerating? No, it's at rest. And remember, though, accelerating means at rest, or it could be traveling at a constant speed, and the net force would still be 0. True. The friction force is what's holding the book on the desk. What'd you say here? You know what? Here's my thought experience. Whenever they talk about friction, I always, and I'm not sure what the answer is, Amy, I go to no friction. And for me, the surface with no friction that I'm most familiar with begins with the letter I. Ice. Okay, so if the desk was made out of ice and it was level, could you still put a book on it? So is friction holding it on? No! And that would be a great, if I'd asked you to explain your answer, that'd be a brilliant explanation. Well, you know what? Stuff sits on ice just fine. Now, if the desk was slanty, that's a whole other, but they haven't mentioned that. Oh, I put that word in there for a reason. So friction, no. Half mark for each of those. Cameron, number 8 is asking me to find what? So read number 8, find the word find, and tell me what they're asking me to find. Now, Cameron is right in that he said the scale reading, but he's wrong, because whenever I say, tell me what a scale is saying, what am I really asking you to find? Kyle, normal force. Because what does a scale measure? Normal force. So I like, by the way, if I haven't told you already, I like number 8, I like number 8, number 8's a nice question. You're going to see it on your test. There's a lot of good physics behind the elevator question. As a matter of fact, and I'll go into this maybe if I have time at the end of the year, this question is what led Albert Einstein, I kid you not, to much of his theory of relativity. Really? Yeah. He just imagined an elevator in outer space. Okay? And we'll take it from there. I don't know if I'll get to relativity this year. I usually get to a couple of days of it at the end of the year, but with our late start this year, probably not. But it's cool. Okay. Oh, and your hint is free body diagrams will help here. So, there's the person in A. What are the forces acting on this person? Get the obvious one. Gravity, which way? Down. And we've said that gravity is mass times acceleration, but the acceleration due to gravity is g, so that is ma in disguise. Is this person in free fall? No, so there must be another force pointing up. Which way is this person accelerating? Which way is this elevator accelerating? So am I going to draw a bigger or a smaller force pointing up than gravity? I usually exaggerate it. What do we call that? The floor. And conveniently, that will also be what the scale reads. Who's winning? Loser is gravity, and that equals F net, which is just MA. Cam, how would I get, because remember, although you said scale, really it's normal force. How would I get the normal force by itself here, kiddo? Add what? It is, I need more specific. So we're trying to get the Fn by itself. What else is on the same side as the Fn? What's in front of the mg? So how could I move it over? Is that what you're telling me to add? If you, because you said add it. Add the mg over. Yes? Smile and nod and look intelligent, right? Mass 60. In the question, 1.2 plus 60 times 9.8. You know what? I think I can do that in my head too, because it's really going to be 60 times 11. 660 newtons? I can do decimals in my head. How many marks is this worth? 2, because it required a free body diagram and rearranging an equation. I would probably give you 1 mark if I saw that, half mark if I saw that, and then a half mark for the answer. Elevator question, the second, part B. What are the forces acting on this person? Get the obvious one. Thank you. Maybe not obvious enough. What else? Is this person in free fall? No. So there is a force pointing up, bigger or smaller, or the same size, bigger or smaller than gravity, because it says accelerating downwards. Okay. So in this case, who's winning? Winner minus loser equals MA. Nick, my friend, what are we trying to get by itself? Now, this time, what's immediately in front of the Fn? No, immediately in front of the F. Right in front, immediately in front of the Fn. Here's your hint. Yeah, I mean, when I say right in front, huh? So how could I get rid of that minus? You know what? I'll plus the Fn to that side. Whilst at the same time, I want to move that to that side. Now, what's invisibly in front of the MA? A plus sign. We just never write it. So how will I move the MA over? So if I hear you correctly, and I think I finally do, you're saying the mg would drop down like a domino. There'd be a minus ma, and that equals the normal force sitting by itself. Is that what you're saying? Okay. I'm going to write Fn on the left-hand side. Did they give me the mass? Yeah, it was 60. G, 9.8. Minus 60, 2.25. Do that one in your head, Mr. Okay, maybe I can. It's going to be 9.8 take away 2 is 7.8, take away 0.2 is 7.6, 7.55. Yeesh. 400, 60 times 7.55. 420 plus 456? I'm off. I'm way off. I'm close, but I couldn't, I missed I didn't carry a 1. Oh, I did that wrong. Oh, I did divide it. Whoops, let's try that again. 60 times, make sure you clear your calculator before you start typing. 453, what did I say, 456? That wasn't bad. I'll take that back, I'm okay with that. I had it to 2 sig figs. Same marking scheme as before. 1 mark for the correct equation, half mark for getting Fn by itself, half mark for the answer. C. What are the forces acting on this person? Get the obvious one. Everybody. Oh, your enthusiasm just overwhelms me this morning. Is this person in free fall? Well, no, the elevator is moving up. So there must be a force up. Bigger, smaller, or the same size? Now, those of you that are really good at this will say same size because you've spotted something. But even if you didn't spot that, even if you focused, even if you focused on the word up and you said, Noah, I think that's bigger. Okay. The nice thing about my tug-of-war method is you'll still get the right answer. Based on this drawing, Justin, who have I drawn bigger, mg or Fn? So who's winning? So it's going to look like this. Winner minus loser equals ma. Now, the key concept here is that. What does that mean if you're at a constant velocity? Not accelerating. So as a number, if I said, tell me the magnitude of the acceleration, you would say A equals 0. What it's really telling you is A equals 0. So what's 60 times 0? Really, you have this. And if I plus the mg over, and so for those of you that said it's a tie, yeah, you're right. Actually, these two arrows should be exactly the same length. But we've just proved why. The normal force is going to be 60 times 9.8. Do that one in your head. Okay, it's going to be 600, take away 12. 588? Yeah. I really am doing these in my head. I grew up without a calculator. It's not that impressive, though. You just learned some tricks when you had to. Last one. The elevator is accelerating downwards at 9.8 meters per second squared in free fall. Okay. This is a job for a free body diagram. What are the forces acting on this person? Get the obvious one. Gravity. What else? Now, I kind of think when you're in free fall and you try standing on a scale, I think it will read 0. But I'm not sure. So here's what I'm going to do, Madison. I'm going to hedge my bet. I'm going to pretend maybe there is a normal force pointing up. But here's what I know. Which way are we accelerating? So who's winning? So I'm going to set up my equation, and I'm hoping I can convince myself that my intuitive gut instinct is right, because my equation would be this. mg minus Fn equals ma. Nick, this is the same equation that you and I dealt with earlier. So you ready, Nick? What's immediately in front of the Fn, the normal force? So to move it over, how could I do that? And I'm going to do that by minus. By the way, I almost always draw the arrow and do that because that keeps me from making a dumb mistake, and it takes all of half a second. Cam, it's good bang for my buck. If you haven't clued in by now, I will show work that's useful but minimal. And I'll also try and do some stuff in my head. So I get this. mg minus ma equals Fn. Let's plug it in. M 60, G 9.8 minus M 60, G 9.8. You know what? I'll bet that even Danielle can do this one in her head. What's 60 times 9.8? Take away 60 times 9.8. And what this means is, if you're in free fall, you're weightless. Not massless, not gravityless. But what I've tried to tell you is what all of you think of as your weight is actually what? The normal force. We call that your apparent weight. And if the normal force is 0, by the way, if you just wrote Fn equals 0 because you just saw it, great, full marks, 2 out of 2. But somebody, I can't remember who, asked me last class about this one. There's the proof. It must read 0. Has to. You can't stand on a scale and get any kind of a measurement if you're in free fall. So when I fell out of an airplane, I mentioned I jumped out of an airplane, I was weightless. Not massless, not gravityless, but I felt weightless. So these are worth 2. Can you give yourself a lovely score, please, out of, count 'em, 23? And could you make sure your name is on them?